I've got a question for all those who are so unsceptical they believe whatever Christopher Monckton says about climate. Why? What is it about him that makes him so believable? Is it his science background as science advisor to Margaret Thatcher?
Or Lord Christopher Monckton, former science advisor to Prime Minister Margaret Thatcher?
Is it the fact that he wrote several peer-reviewed scientific papers, so he must know what he's talking about?
Now, when I write a peer-reviewed paper in a scientific journal...
Or is it simply the weight of his irrefutable arguments, which you've checked for yourselves, and show quite clearly that his fellow scientists have got things wrong? Well, we can dispense with the first two very quickly. The idea that Monckton has some kind of a science background may have started with an article he wrote in 2006, claiming to have advised Margaret Thatcher on scientific scams and scares. In fact, he has no science background. He has a degree in classics and a diploma in journalism. And if he was Margaret Thatcher's science advisor, let's check her autobiography to see what she thought of his advice. That's funny. Margaret Thatcher says her science advisor in the policy unit was George Guy's. Well, maybe Monckton was the man who advised her specifically on climate change. After all, he says so himself.
Now, Margaret Thatcher, whom I used to advise on this question 25 years ago...
No, Margaret Thatcher disagrees. She specifically says George Guy's advised her on climate change, as a result of which she made a speech about it to the Royal Society and set up the Climatic Research Unit. So what role did Monckton play in her life? Well, let's take a look in the index. Molotov, Molyneux, monetarism? In the entire 900-page autobiography, it seems Margaret Thatcher couldn't find room for a single mention of one of her most important advisers. To be fair to Monckton, he started out in his climate campaign freely admitting he has no qualifications as a scientist.
So you may be thinking, what right does a non-scientist, albeit a former political advisor to prime ministers, have to talk to us about the science of climate change?
What about that peer-reviewed scientific paper? No, Monckton never wrote one. He was invited to submit an opinion piece to the newsletter of the American Physical Society as part of a debate. This isn't one of the APS's peer-reviewed journals. It's a forum for opinions, as the editorial statement of purpose shows. Monckton's insistence that his piece was peer-reviewed even led the editor to publish a response, pointing out that it wasn't. By now, I'm sure a lot of Monckton fans will be saying, what does it matter if he isn't a scientist? He was never Margaret Thatcher's science advisor and has never published a scientific paper. If he's not presenting his own theories, but just correctly presenting data and inferences from the scientific literature, he doesn't need a science background. And I agree. But all this is conditional on these facts and these quotes being correct. If anyone thinks we should unquestioningly believe whatever Monckton says and that checking his facts is somehow unfair, I'm going to call on someone who's going to support me throughout these videos.
Skepticism is the highest of duties, blind faith, the one unpardonable sin.
Yes, Christopher Monckton himself.
Now, I'm not going to give you, as he did in that film, my opinion about climate change, because it is as worthless as his. Everything I say, I can and will, on request, verify, either in the data or with equations or in the peer-reviewed literature.
Then that makes things very easy. Where Mr. Monckton gives sources, we can check them to make sure he's quoting them correctly. Where he doesn't give sources, we'll find out if he has any. Because as we'll see later in this video, I wrote to Mr. Monckton asking him to verify certain facts and asking for his sources, but the results were quite extraordinary, because I discovered that the person who can best debunk Christopher Monckton is Christopher Monckton himself. So where do we start?
So here's the first one. We've had 9 years of a global cooling trend since the 1st of January 2001. There has been global cooling for the last 8 or 9 years.
Well, if Monckton is quoting from the data and the scientific literature, what does the data and the scientific literature say about this? A paper published in 2008 by the National Climate Centre in Australia looked at temperature data from the world's 3 terrestrial temperature monitoring bodies and concluded, in all 3 data sets, the linear trend over 1998 to 2007 is upward, i.e. one of warming, even if the warming is weaker in the British data set than in the American data sets. 1998 was even warmer than Monckton's starting point, 2001. In addition, an independent group of statisticians was given the raw data by the Associated Press without being told what it was. The experts found no true temperature declines over time. And the AP quoted NOAA Climate Monitoring Chief Deki Arndt as saying, "The last 10 years are the warmest 10-year period of the modern record. Even if you analyse the trend during that 10 years, the trend is actually positive, which means warming." So if temperature monitoring bodies and reviewers and statisticians say the trend is up, what experts is Monckton citing to show the trend is down?
And what that looks to me like is a fairly hefty, and indeed it is, statistically significant rate of fall.
It turns out, none. Monckton is giving us his own opinion, and since he has no expertise in this field, he's quite right to say that his opinion is as worthless as Al Gore's. For a start, you can't tell statistical significance just by looking at a graph. As I explained in an earlier video, statistically significant doesn't mean notable. It has a specific mathematical meaning and has to be calculated. But statistically significant or not, how did Monckton end up drawing a downward trend line when all the experts insist that the trend is up? It turns out the answer is very simple. It all depends on where you choose your start and end points. Global temperatures are subject to short-term cyclical factors, from the El Niño Southern Oscillation every few years to the solar cycle every 11 years. So if you choose a start and end point over a very short period of time, with strong warming factors such as El Niño near the start, and an exceptional solar minimum towards the end, these natural background fluctuations will skew the result. John Grego, a professor of statistics at the University of South Carolina, told the AP, "If you look at the data and sort of cherry-pick a micro-trend within a bigger trend, that technique is particularly suspect." If Monckton fans find that hard to believe, I have someone here who'll tell you exactly the same thing.
If you choose your start points and your end points carefully enough, you can make it look as though any trend you want is happening. We've had 9 years of a global cooling trend since the 1st of January 2001.
So how do climate scientists and statisticians get around this problem? As I explained in Climate Change, Is the Earth Cooling? For one thing, they look at time periods over decades rather than just a few years. When you expand the timeline and look at the last few years in context, things look a little different. They can also correct this data for anomalies like the El Niño Southern Oscillation. But most commonly, they even out the background fluctuations by taking a moving average every 5, 10 or 11 years. That way, the underlying trend becomes clear. Temperatures started moving upwards in the mid to late 1970s, and they're still moving up today.
So then we go on to Arctic sea ice, which follows a regular kind of sine wave. It comes and goes with the seasons. There's lots of it during the winter, not so much during the summer. Nothing particularly to worry about in that graph there. In fact, there was a temporary loss of Arctic sea ice at the summer minimum in 2007. That's the left-hand globe there. But then by 2008, it's the purple area, which is the sea ice. That's just the way the computer graphics from the satellite do it. By 2008, half of that missing ice had come back. By 2009, nearly all of it had come back. So we're not looking at a sort of long-term systematic loss of ice in the Arctic.
Now this surprised me because research papers show there's been a steady loss of Arctic sea ice for 30 years. Since Monckton says everything he tells us comes from the data and the scientific literature, then it should be easy to discover who's right. All I needed was Monckton's source. As so often happens, Monckton doesn't give a source, so I wrote to him asking for one, and he wrote back, "For Arctic and Antarctic sea ice, see the monthly CO2 reports that I produce for the Science and Public Policy Institute. The graphs are all explained and sourced." There was only one graph that specifically related to Arctic ice, going back just 10 years, and while the graph was sourced, the interpretation of it was not. So I asked Monckton again for the sources that back up his claim that we're not looking at a sort of long-term systematic loss of ice in the Arctic. He came back with this. Arctic sea ice has indeed been declining in extent for 30 years, and the monthly CO2 reports fairly reflect this. What was that first bit again? Arctic sea ice has indeed been declining in extent for 30 years. But didn't you just tell everyone...
We're not looking at a sort of long-term systematic loss of ice in the Arctic.
Once again, which Monckton should we believe? Writing in the monthly CO2 report, Monckton does indeed accept that there has been a decline. There has been a very slight decline in the trend of global sea ice extent over the decades, chiefly attributable to a loss of sea ice in the Arctic during the summer. So his preaching of no long-term decline is not only unsupported by the data and the scientific literature, even Monckton accepts that it's wrong. And yet the arguments he gives to his audiences seem absolutely convincing. So let's see how Monckton managed to persuade them.
If you choose your start points and your end points carefully enough, you can make it look as though any trend you want is happening.
In this case, Monckton's start point and end point were embarrassingly close together. His start point was just 2 years earlier, in 2007, when ice extent was at a record low. This wasn't primarily caused by global warming, it was the result of winds and currents, and Monckton acknowledges this. But there are 30 years of data going back to when satellite images were first taken. This is what it shows. As Monckton admits, when you press for a source, it's a 30-year decline. And if we go back even further, we can see the last 30 years in context. So Monckton seems to be giving one message to his audiences and in videos, but a very different message if anyone takes the trouble to check his facts in more detail. As I've said before, when someone makes a surprising claim, the best way to disprove it is to force them to give up their source, however reluctantly. 90% of the time, finding the source, or the non-existence of a source, gets you to the truth.
How many of you have heard that Greenland is melting away? Yes, that's right, you've all heard that. Right. Here is a paper by Johannessen et al., very diligent Danish researcher, using laser altimetry. And what he found was that between 1992 and 2003, the average thickness of the vast Greenland ice sheet increased by 2 inches a year.
Up to a point, Lord Copper. Once again, resolving the differences between Monckton and the climatologists is fairly easy, because both claim to cite the scientific literature. And here Monckton actually gives us a source, a paper by Johannessen published in 2005. If Johannessen's altimetry measurements show a thickening of the Greenland ice sheet, and this is not disputed by other researchers, then Monckton doesn't need to convince me with pictures of ice getting thicker. What I am going to do is check what Monckton claims. I'm going to read Johannessen's paper. And it turns out he did not report that the average thickness of the Greenland ice sheet has increased. On the contrary, he says we can't make that assessment because his study only measured the interior of Greenland at an altitude of 1,500 meters or more. The title of the paper alone should have been a clue. It's conceivable, Johannessen says, that Greenland is losing more ice through ablation, that's melting, at the lower altitudes than it's gaining ice at the higher altitudes he measured. That's putting what he said into plain English, but if Monckton fans find it hard to believe Monckton got this wrong, please pause the video and read what Johannessen wrote for yourselves, or look up the paper on the internet and read the whole thing. And since that paper was published, other studies have shown that the ice loss at lower altitudes is greater than the ice gain that Johannessen measured. In other words, there's a net loss of ice from Greenland. 2 definitive papers were published in 2006. So these were available to Monckton at the time he made his speeches, telling everyone that there was no net loss. Another thing that Monckton missed is Johannessen's conclusion that the increase in ice at higher altitudes could be due to a decadal climate system like the North Atlantic Oscillation. What's more, he says this increase was predicted by climate models.
I am simply going to tell you a series of facts from the science and the data and the peer-reviewed literature, and I am going to allow you to draw the conclusion for yourselves.
I'm not going to presume that Monckton is deliberately trying to mislead his audiences. As always, I can't discern motivation. I can only check the information and show whether it's right or wrong. But assuming Monckton is sincere in his beliefs, then there are only 2 possible conclusions. Either he didn't read or he misunderstood the scientific studies that have measured the loss of ice in Greenland, and either he didn't read or he misunderstood the one paper he quoted upon which his entire argument rests. I would urge Monckton fans to do what I did. If he doesn't give a source, be skeptical. If he does give a source, read it.
And that's what the scientific method is about. It's about checking.
Monckton gets so many things wrong, and it's so easy to show that he's wrong, that I've got at least 2 more videos to do on him. And in case they get removed from YouTube, please copy and mirror them.